Okay, so today I'm going to be talking about bqplot, a library we developed while I was at Bloomberg. If you want to follow along, the repository is on GitHub. Just to start with, what is bqplot? So bqplot is an interactive plotting library for the Jupyter Notebook, like the slide says. What does that mean? It means that it's, we believe the right way to do interactive visualization in the notebook. It's Apache licensed, it's on GitHub, open source by Bloomberg. And usually when I talk about this, or any of us talk about this, the first reaction we get is a collective sigh, like really another Python plotting library. I mean, come on, that's ridiculous. So why learn bqplot? And one of the things, I can get Keynote to show GIFs, so I pulled up the GIFs over here. One of the big reasons we like bqplot is because, well, this is 19 lines of Python code. Generating something like a 538 map is only 8 lines of Python code. And we're going to show you the magic that makes that possible. Okay, let's go back here. All right. Okay, maybe zoom a bit. Yeah. All right. That might be too much. Okay. So what makes bqplot special? Well, let's start with something simple. Can it plot a line chart? And the answer is yes. So if we generate a set of data, we have two APIs. One is a very matplotlib-esque API. I use the word esque because we changed some things we thought worked better with our library. You can just do plt.scatter. And there you go, you have your scatter plot. So, but the cool thing is this isn't just a PNG rendered on the page. These are actual SVG elements. All of these are little SVG circles you can do an inspect. So you can do seamless zooming, panning, resetting. You can save the plot. That's really a web element right there. The cool thing about bqplot is once you define a plot, every aspect of the plot is an interactive widget. So what that means is if you do something, I'm going to need both my hands for this. So if you do something like take the scatter plot and set the Y, that's going to change the original plot without re-rendering any of it, basically. Since this is all based on D3 and SVG, you definitely want some cool animations because otherwise it's not worth it. So let's try that, and let's try to rerun the cell. So so bqplot allows pretty much seamless animation of your plots if you're doing any sort of interactivity. As I said, every aspect of the plot is an interactive widget, so you can change the colors, you can change the marker. That's going to change the original plot. The best part about bqplot, the reason interactivity is so easy, is because it's based on the ipyWidgets framework. So what that means is that if we define something like a function, say foo, we can say that for our scatter plot, call the function foo whenever the attribute y changes. So let's try that. We can set enable move to be true. What that's going to let us do is move the points. So let's see if we change the y values, what happens. And voila, that's going to call the foo function that we defined. And just to kind of prove that it's not much of a hack, you can always see what exactly is passed to the function. So if you move it, you see that the function is given the old values of the scatter plot and the new values along with a bunch of other data, like what point was hovered, who the owner is. So essentially, as long as you define a function and attach it to an attribute, it's going to be called whenever the plot is interacted with, either by the Python side or by the user on the front end. So that's kind of how we use bqplot. We use it to really bind together a set of functions with visualizations. What makes it very powerful is that it is it's a full-scale visualization library. We have a matplotlib type API, but we also have an object model API, which allows you to construct a figure using kind of allows you to construct a plot using kind of a grammar of graphics based approach. So you define each of the things that you require. So for a plot, it's typically composed of a scale, which maps the data to pixels. So you can define your scales, you can define the type of plot that you want, you can create axes and put it all together into a single figure. and that's going to give you the same plot. We allow you to specify most attributes in the form of data. So you can define something like color data. In this case, let's say it's a set of times you either, if that's a stock price, a set of times you either bought or sold the stock. Like any other scale, colors are also provided with color scales. And all you need to do is set the scales for the scatter plot and set the color data. And it's going to color it according to the values that you pass. The cool thing about the grammar of graphics approach is it gives you a framework to compose multiple different types of charts into a single figure. So if you want another bar chart, you just need to make sure it shares the scales with the scatter plot, and then you should be all set. That's going to put a chart back. So it's easy to compose many different visualizations onto the single figure. We also allow probably some of the quickest interactivity that I've seen. So if you have, let's say, winner data, like who won each county in, say, the 2008 election, what you can do is you can call upon a tooltip. You can define what fields you would like and what names you want to show when you hover over them. And you can have a full-scale map in just, this line of code right here. And when you hover over, that's going to tell you who won which county. Oops, and there we go. So you can do kind of a county level analysis and see who won which county quite quickly. The great thing about the tooltips is any widget is an admissible tooltip. So if you have something like a world map, you can have a line chart as part of the tooltip. So you can, and a good exercise if you want to get into bqplot is listen to which country you're hovering over and change the line chart according to that. Let's say if you want to plot the historical GDP per country, this would be a nice way to do it. So we also allow we also have the notion of selections. So basically, in a plot, you can always click on a set of points to select them. So here you can see that you can select one or multiple points. Selected itself is a trait, so you can always observe it. So you can do other things when you're selecting. Say, for example, print it, and it's going to tell you which points are selected. You also have D3-esque selections like a brush selector. So if you select a set of points, it's going to tell you what points were selected. So why is this useful for scientific computation? We typically try to mix, one, it allows you to have these kind of JavaScript level interactivity with your Python, scientific stack. So say if you were using scikit-learn, you could have a set of data and you could fit a linear regression to it. Basically what you can do is you can move the points on the scatter and refit the linear regression. So in this case, all I'm doing is observing when the y is changing, and I'm calling point move and refitting it and changing the y of a line that's being plotted. So if I move that, you see the regression line is going to move along with it. That's pretty simple. I think it's just 4 or 5 lines of code. You can also do as I mentioned at the start, that basically bqplot is part of the ipy widgets framework. So it interacts well with any of the other libraries written on the ipy widget stack, whether it's py3.js or ipy widgets itself. So you can always use ipy widgets with it. So say you wanted to use a slider to control the order of a polynomial that you're fitting, you could always increase the order. In bqplot, you can add points as you go and see how the polynomial is refitting. That's kind of how we use it. So we use it to interact live with all the different computations that we're doing, to kind of use it to drill down into what the computation really is. And in terms of machine learning, which is the thing everyone wants to talk about these days, we use it to visualize our data. We have marks, which are types of plots, which cover pretty much all the different types of visualizations: bar charts, histograms, box plots, maps, you name it, we have it. We also have a canvas-based image mark, so you can display images, in this case, the famous MNIST data set. Yeah, and so this you could do with matplotlib quite easily, but we might want to visualize exactly what the structure of our data is. So we could try some kind of manifold learning like t-SNE. So in that case, if we, by the way, all these notebooks are on GitHub, so we do a t-SNE on all of our different images. You see a set of clusters emerge, but you don't really, you want to see what the different images that are being confused are, so you can just hover over and say, oh, okay, that's the one that's that's very close to a 5, and you can see exactly where exactly your separability issues lie, and really kind of investigate your data at a much higher, a much more detailed level. See if you need to add any more features or things like that. So yeah, so that's kind of how we use bqplot. As I mentioned, so it works with both the notebook and Jupyter Lab, and it's part of the growing ecosystem of the ipy widgets libraries. So we use it, you can combine it with Volume, ipy Volume for in-depth 3D visualizations, Py3JS if you like 3JS, ipy Leaflet if you want to do kind of intensive geo work. The bqplot team is, I think, mostly here. All of us did this while we were at Bloomberg and have since continued developing it. And we are looking for more and more developers like any open source project. So if you're particularly good with D3 or interested in building cool applications, feel free to submit a PR. I'm going to hand it over to Shri, who's going to do some very flashy demos because, it's not fun without any razzle dazzle. So here's Srinivas Sankara.
Thanks, Dhruv. Hello, everyone. Hopefully, after all the details that Dhruv gave you, I'll be able to show some nice demos which will convince you to use bqplot. So the first example that I'm going to go over, one second, is called mobile patent suits. So basically, it is a data set of, in all the mobile companies, who is suing who. So, it's actually interesting. So I'm just trying to get this up. So this was first done by Thomson Reuters in a visualization. Then Mike Bostock had this. So I'll just try to pull it up. Yeah, the internet is not that great, I have to say here. But. Yeah, this is Mike Bostock's visualization. So every node here is a company, and it is an improvement over the Thomson Reuters one. And so what we have here is this. So basically, this is the data that we are getting. And the cool thing about this is, as data scientists and also as researchers, we are not that familiar with JavaScript. So you can construct all these visualizations just in Python. So here what we have is essentially the same thing, where each node represents a company, and the code that you need to generate this is just this much, and it's mostly like formatting the data in a format which is amenable to bqplot. And you can also add like cool D3 interactivity, like you can hover over a company and just see only those which are being sued and which are suing that company. So you can get a much more detailed overview of what is going on in the mobile space. So this, you can check out all these demos in the repo that Dhruv shared. So the next demo that I have is visualizing the correlation matrix. So usually what people say is, in a crisis, all the stocks, they become more correlated. And we wanted to check if that is true. So the traditional way of doing this would be, okay, I have to zoom in. Yeah. Sure, I'll try that. View, toggle head bar. Sorry, I'm pretty bad with the Mac. I have a Lenovo PC. Yeah. So what we have on the left here is the price series of the Dow Jones and Dow Jones Industrial Index, which contains 30 stocks. And what we have on the right is the correlation matrix of those 30 stocks over the entire period. So if you want to test the hypothesis that, okay, in crises, they do become more correlated, So all you have to do here is, okay, 1 second. Yeah, I'll do that. So I just, yeah, I'll just rerun the cell because, yeah, this is kind. All right, so this is like one more view of way to select a subset of data points. So basically, you can storm through the data very quickly and understand what is going on. So like if you want to analyze what is going on in this big drop, all you have to do is to just move the mouse down so that it looks at only that interval, and you can see that the correlation matrix is much more red, which means that everything is more correlated. And you can also analyze on different periods and get a global understanding of how the correlation matrix is behaving across different time scales. And all you needed to do for this was just write a small event handler and then just construct the correlation matrix for that part of the data. So yeah, that is all you needed to do to construct this. So next, I'll go into another example. 1 second. The Jupyter Lab? Okay. Yeah. So here what we have is, so I'll just hide this guy. So everybody knows the wealth of nations. So it is a visualization of how the GDP and the income per capita for different countries are evolving over time. So it is a very cool visualization. I'll go into a little bit of detail about how to construct this using bqplot and show you how easy it is to do it. So first, we just do a few imports, and then we just read the JSON file, which has the data. And then we have a few functions just to clean the data, to remove the nans, and then to extrapolate and interpolate for countries which don't have like very clean data. So once we do that, we have the data that we want to see. So if we just look at it, so yeah, we have a data frame where in each cell we have the, so, okay, 1 sec. So we have each country, the region it belongs to, and then the income per capita and the GDP data. So next, so we have just a utility function here, which just takes in the year as the input and returns you the GDP and the income per capita for that country. So next, as Dhruv showed you, you can easily define a tooltip where we are saying the labels that we want are the country name, the income per capita, and the life expectancy. And after that, we just have a label for displaying what year it is. And next, we create the scales and the axes. So we want a log scale for the X because the income per capita does change quite a bit. So you want everything in a log scale rather than just in a linear scale. And so next, the thing we want to visualize is a scatter, where in the X we have the income per capita, and in the Y we have the life expectancy. And we added one more twist to the Wealth of Nations usual thing, which I will show you, and I'll go over it in just a bit. So once we have that, we'll create the figure which we want to display, and we have a slider to control the year. So yeah, here we have the Wealth of Nations. I'll just zoom out a bit. Yeah. So here we have the Wealth of Nations. We have a slider here, which we can change to see how the different countries, the life expectancy and income per capita is changing. So one good thing we notice here is everything is moving towards the top right corner, which is what we would want. People are living longer and income is increasing. So we can also animate this using just this play button, which is an ipy widget, which you can link up to it. So basically what it does is it creates the whole animation for you. it sets the different values for the slider and then goes through the entire animation for you. So we can have that, so we can stop it. And one thing we added to the traditional wealth of nations is basically you can hover over any country and see its entire path. So if you hover over the US here, you see how the income and life expectancy evolved over time. So, and all you needed to do for that was, if you go back to the code here, yeah, you just needed to define a line and basically set its visibility and change the data for it. So whenever we hover on a point, what we are doing is setting the X and the Y for the line appropriately, and then changing the visible to true or false. So with that, you can create this very complicated visualization in very less code. And I don't know if you've noticed, but this is in Jupyter Lab, which is the new version of the Jupyter Notebook. So basically, so bqplot works with Jupyter Lab, and yeah, we're pretty happy to say that. So the next thing we want to look at is basically, as Dhruv said, everybody wants to do machine learning. So we also wanted, how many of you, just as a show of hands, how many of you have used TensorFlow, like in some capacity? Okay, a good 30 to 40%. So along with TensorFlow, there comes a utility called TensorBoard, which is a visualization which helps you understand what the neural network is doing. So we built a counterpart for TensorBoard using bqplot. And basically, it's, yeah, I can show you a live demo here, where basically I'm training on the data set, which is the credit data set. So the data is like this. We have a set of features: the age, the debt ratio of the person, the number of dependents that he has, etc. And we are supposed to predict if the person will default on his payments or not. So so here what we have on the Y is the area under the curve, area under the rock curve. So higher is better. So here we can see how the training is evolving. So we initially see that the train and test, the performance is not that good. But overall, as time is progressing, we see that the performance is getting better. And this is typically what we would want from our network. And you can adjust different parameters by looking at how this particular curve is evolving. Apart from that, we have a pretty complex visualization here. So using the same graph that I showed you, so we can construct an entire neural network here. And so once we construct the entire neural network, we can visualize different things. Like we can see what are the weights which are for each of the neuron at each epoch. So if you just hover on this guy, you basically see what are the weights that are there, and you see how the weights are evolving as training is proceeding. So you see that the weights have more or less stabilized. So one more thing you can look at is the gradients. And basically, you can analyze the entire network and get a very good picture of what it is doing and how to modify your parameters and everything. So for this, the plotting code is very less. Most of the code is like computing all the statistics. And yeah, so you can use it for analyzing neural networks and understand what it's doing and build complex visualizations very easily. So after that, yeah, that is pretty much all that I have. So yeah, we developed this library while we were working at Bloomberg. And you can reach out to us if you have any questions. And I'm happy to take questions now. Dhruv, you want to?
Thank you very much. Just working? Yes, yes. Thank you very much. Do we have any questions?
Thanks. So bqplot uses SVG graphics. How well does it scale for large data sets? And at what point do you maybe want to try and use something besides bqplot?
So there are some canvas-based marks as well. Sorry. It doesn't scale well, but there are canvas-based marks that we are planning, and there are already some that are inside the code. So that would be more for the bigger data sets.
And can I add? So with Canvas also, there is like a pro and a con. The pro is that you can visualize a lot of data, but then the con is you don't have the interactivity at a point level, like how Dhruv showed. You can move a particular point, create your own scenario, and see how your function is affected by that. So yeah, we try to offer both. Like we have the canvas-based image and heat map mark, but yeah, that is.
So I'm curious, so I mean, this is SVG, so presumably there's a way to also export that to an SVG file with bqplot? And also I'm curious, can you export the animations to like a MP4 or something like that?
Yeah, we do have a save as SVG. Sylvain wrote it a long time ago. But right now, one way to export it is to just use the widget mechanism and just embed. If you hit embed widgets, it generates. That's a big one. That was a mistake. It generates the JavaScript for you, so you can just put that inside your
I was thinking more like along the lines if I wanted to include one of these bqplot figures in a paper. So like maybe I have a blog post and I create this nice interactive figure for my blog post, but then it's also I want to have a static version of that figure in my like published paper.
I think we have a save as we have a save PNG function for each figure. I think there's a save SVG function too, which returns that to you.
Cool, thanks.
And regarding the interactivity, so if you, all the interactivity that is on the JavaScript side automatically comes to you with the embed widgets. And if you have like Python-based interaction, that is you're computing something on the Python side, then if you have a remote kernel that you're connecting to, then that can also be taken care of. So.
Is there a way to update the charts based on the data changing in real time or near real time?
Yeah, so if you have a callback for when your data changes, like the way you see in the neural net example, Shri scrolled up during it, but basically, it's control enter. So basically, every time there's at the end of each epoch in training, Keras has a callback function. So essentially, in that callback function, all we do is we change the line. So it's kind of like, we use it for streaming data too. As long as you have a callback, you can just change the chart in your callback, and that will create the streaming effect.
Okay, great. Let's thank our speakers once more.